Hello, everyone. Our final year project is about data analysis and visualization of NYC EV fleet station network. And our team members are Janet Sylvester, George Pitsi, Lakshmi Narasimhan, Manmohan, Vijay Bhaskar, Kushbu Aswin, Paramal. So we have also created a link of the presentation which will be shared once after this recording is done. So this project is about EV vehicles. So it is like expanding the charging infrastructure, which is essential to achieve the government's target of capturing a 50% market share for electric cars in new vehicle registration by 2030. That's the target. To accomplish this, it is crucial to assess the existing fleet charging network in New York City and gain valuable insights for potential upgrades in the electric vehicle infrastructure. The data, we have obtained the data from NYC Open Data, and the data set provider is Department of Citywide Administration Services. And we have provided the source link, also the API endpoint link along with this report. So before starting the program, we need to make sure that all the necessary PIP installation has been done, particularly on Conda, SODA-P, plot PY, Folium, and we also require plot device, matplot, pandas, numpy, Socrata as well. So to import this data directly from the website, we used authenticated client credentials, which is necessary for this. We also created a profile in Socrata, and we also need the required credentials, including like my app token, username, and password. So which we have provided along with the code. The data we have retrieved from the NYC Open Data, where the API file is in JSON format, and we converted it into the Python dictionary using the SODA-P library. So here comes the Python script. So initially we imported the necessary libraries into the code, and then we started moving ahead with programming. So initially the data sets has 678 rows and 17 columns. So, and there were uneven data sets here and there in each rows and each columns. So we need to clean the data. So in order to clean it, so we have used the right method. So first, initially we we took the data set using the JSON thing, and we converted the directories to pandas, and then we did the cleaning process by removing all the null values. So this is the output which we got at the initial after cleaning the data set. So next is the visualization. So the extracted data from the previous step, that after the cleaning and analyzing, after cleaning, we did the visualization and analyzing of the electric vehicle fleet station for the NYC. So we have separated into several categories. And the first one is analyzing the placement of the charging station in NYC. So in NYC, there are a lot of EV fleet stations, and the density, we have made a density plot to understand the location of the charging station in each boroughs. So based on the population of each boroughs, we can determine the charging station or which one has the best efficient use. So we created a scatter plot for it, and then we created a density map. We updated the layout using margin and title, and we were able to put it in longitude and latitude base, and you can see the density of the fleets whichever is present over here. So here you can observe that Manhattan area has more number of charging fleets than compared to other areas. Manhattan and Queens, I believe, yeah, this is Queens, and you can see that. So here, according to the as far as from the given map above and the boroughs, Manhattan and Queens are the two boroughs with majority of the charging stations. For better service, there needs to be more EV infrastructure involved in these boroughs. So next one, we consider visualization of each agency's charging port capacity. So here we are trying to visualize how many ports each NYC, like New York City agency, has for the EV charging station. So these are all the agencies which the dataset has, and here DPR has the more number of ports, and the second comes DSNY and DEP. So from this bar chart, it's easily identified that uh, which agency has the most number of ports. And the first three belongs to the DPR, DSNY, and DEP. The next is the visualization of agencies in NYC based on their operational size. So here we are making a bar chart which allows us to see the agencies in NYC. The graph accounts the operational capacity of the station setup for various agencies in the New York City for 5 different boroughs. So you can see the graph over here. Since our objective is to rank the agencies, the count for each agencies is calculated based on the agency numbers, and they are sorted in the descending order. So in the above plot, you can see that the agency DPR, DSNY, DEP, and DOT are greatly contributed to the availability of electric vehicle charging station in the New York City. We have also coded the citations for each and every plot. So the next is the analyzing the number of charging ports using violin plot. So here, the infrastructure for charging electric vehicle will need to be adequate for the switch from internal combustion engines. So different charging stations have varying numbers of ports. In order to determine where future improvements could be made, we need to examine the parameters. Like here, we have taken the parameters of charging station, charging port capacity, and the boroughs. So this can be interpreted using a violin plot. So a violin plot is used to represent the charging station in each boroughs, which were grouped according to the number of the charging ports. So we have grouped it based on the boroughs. So you can, in this graph, you can see the violin plot for each boroughs: Queens, Brooklyn, Manhattan, Bronx, and Staten. So this violin plot reveals that in all boroughs, there are more stations with a single port than there with 2 ports. So here you can see the single ports are more than compared to 2 ports. It's a pretty good comparison, which we have taken it. So we could see the right away that each station has to have more charging ports in order to support the switch to EV smoothly. Yeah. The next one is we have taken consideration of mapping using Folium visualization library. So here we have done a map. So it is similar to the violin plot. The comparison of the it gives a good comparison with the violin plot. So here the charging ports are projected along with their location. With we have also given a color code with red and blue, and we have used Folium library in order to create a map and visualize the related parameters to the previous violin plot. So this is the respective code. So initially we set the location and title of the map, then we filter out the rows with missing latitude and longitude values. Then we created a map object using Folium. We added markers to the map, and then we added the title to the map, and then we saved it in a HCL format. So here you can see in the New York City, the dots of red and blue. So with just one charging port shown in red color. So red colors are identified as one charging port, and the blues are identified as two charging ports. So here more consideration has to be given in the charging stations in densely populated boroughs, like for example, Manhattan, Queens, and Bronx, to increase their capacity. The next one is the station capacity and charging port in boroughs. So we are comparing the station and the charging port. So we will now create a radar chart for this to show the number of charging ports and the charging stations available in each area. This gives a better understanding of EV infrastructure in each boroughs. So this is the code we have inputted in. So for initially we grouped the data by borough and summing up the number of part columns, and then we created the radar chart, and then setting up the title alignment for it, grouping up the data, creating radar chart for station name by boroughs, setting title alignments, and then we show the figure of it. So here at the first picture, you can see borough versus number of charging port. Here, the number of charging ports are more in Queens when compared to others, and the second would be Brooklyn. But the more number of charging ports are located in Queens area. And the same as for charging stations as well. So the stations are more at Queens than compared to rest of the 4 boroughs. And the second most highest charging stations are at Brooklyn. So here from these radar charts, we can infer that the Queens is the most suited to meet the demand of EV charging. They are ahead of Brooklyn in terms of the greater number of charging stations as well as the charging ports. We also can come to a point that EV infrastructure is weak in Bronx, Manhattan, and Staten Island. And that has to be, and the station and the port capacity has to be increased further over here. And the next one is we have done an analysis for vehicles operating in each boroughs. So we made a pie chart for this. So here the like our chart demonstrates which is the best advanced EV infrastructure. This prompts us to wonder which borough has the most census tract takers. So on the data, we are grouping and aggregating. To be more precise, we sorted the data by borough column and then added the census tract column, sums of for each borough, and made a pie chart to show how borough percentages of the overall census tract were distributed. So we grouped the total census tract according to each boroughs. The code, initially we did the code for that, and then we created a pie chart using matplotlib package, and then we displayed it. So here from the output, you can see that vehicle sensors in each boroughs. So Queens has more number of percentage than compared to rest of the boroughs. So it is well clear that Queens has the largest population density when compared to other boroughs. And because of Queens having a largest density of population, then it is quite enough for like we can come to a conclusion that it would be necessary for Queens to have the finest EV infrastructure, which is equivalent to our conclusion, which we did from the radar map, that Queens has the most number of ports and the charging station. And the next one is agency operation in boroughs. Here we are attempting to use a pie chart to illustrate the amount of agencies that are present at each boroughs. So the coding is for, like, we have made a coding for sorting the information from boroughs agencies using the group 5 function. And then we set the color for it, created a method to show the real values in the pie chart. And then we used pie plot to create the pie chart. So from this plot, you can see the number of agencies operating in each borough. Here, you can quite see that Brooklyn has more number of agencies, and the second comes up with the Queens and then the Staten Island. So it is well clear that Queens has more number of agencies. So yeah, so it has Queen has like in Queens, their business operation is pretty good than compared to other boroughs. And also the Bronx, which is the lowest number, it has less number of agencies over there. So to conclude further, the study suggests us that the government is falling short of its intended goal to facilitate further a seamless transition to electric vehicles and lower carbon emissions. EV infrastructure must be improved. So this helps to reduce the carbon emissions and helps the EV company to build further and to give a pretty good environment. And also the study identifies the key areas where effort should be focused in order to meet the government goals while making the best use of available resources. That's all. Thank you.